All right, so to review for the quiz that is tomorrow, and whether or not you are here or not, if you're out of class for beta, you need to watch this video and do the review yourself, and then everyone will be taking the quiz tomorrow. Okay, so for 9.1, we're just gonna kind of go around the room, answering these, and then talk about if you have any question about how we got the answer we got, please don't hesitate to speak up, okay? All right, so for number 1 through 7, we're going to use this graph. So for number 1, which is the fastest runner and how do you know? So we're just going to start over on the other side. Taylor, which one do you have as the fastest runner and how do you know? Okay. While you're doing that, I'll skip you and I'll come back to you. See if you can get it to work. If not, I'll see if I can help you. All right, Mary, what do you have as which one of those is the fastest runner? Runner B, and why? Right. Before you do any math, you can just see that runner B's line has a steeper slope, and so that is the fastest rate of increase, which means they're running the fastest speed. Okay. If you can't get it that way, Taylor, maybe go into your Google Drive and open your Cami folder and see if it's there. Okay. All right. Number 2, how fast is runner A going? Jake, what did you decide for how fast runner A is going? All right, and I'm not looking at a key, so we're just going to work this together. You said 1 mile an hour? All right, so yes. So runner A is going from 2 miles to 3 miles in 1 hour. And so that is 1 mile per hour because it's 1 over 1, which is just 1 mile per hour. Remember, if you've got distance and time, your answer is going to be miles per hour. All right, how fast is runner B going, Laura? 3 miles per hour. And again, runner B is from here to here in this 1 hour. And so that's 3 miles per hour. Good. And does that hold true? We said that runner B was the fastest runner because he had the steepest slope. And so if you look at their speeds, runner B does have a faster speed than runner A. So our math holds true to what we thought with the steeper slope. If you get a faster rate for the runner that you think should be slower, you probably made a math error somewhere and you need to go back and kind of see where you made it. Taylor, did it work? Okay, good. All right, so both runners have different y-intercepts. What does this mean relative to the graph? Shayna, what does it mean since they both have different y-intercepts? We've got runner B that's y-intercept is right here, and runner A's y-intercept is right here. They're different. What does it mean? What does the y-axis talk about? Or what does the y-axis address? Yeah, their y-intercepts are different because they started at different places. Because our y-intercept's name right here is distance from school, if one starts on the y-axis down here and the other one starts up here, then it means they didn't start at the same distance from the school. Okay? All right, good. At what time will runner A and runner B meet? Gage? Yeah, at 1 hour, because this is their meeting point right here. And their meeting point, since the question is asking time, the meeting point is at 1 hour or after 1 hour. Good. Let's see. Grace, at what time will runner A and runner B meet? Oh, I already did that. Sorry. I wrote it in the wrong one. There we go. Express their meeting point as an ordered pair. There we go. Yeah. 1, 3. Ordered pairs are always X first, then Y, and then they're in the soft brackets. Okay. Let's see. What does the X value of this ordered pair represent? Lexus? Yep. It represents the hours. And if you wanted to get really detailed, hours since leaving the school. And what does the y value represent, Michaela? Distance what? Yep, from, there you go. All right, very good. After 2 hours of running, where would runner A be? Bryn? Yeah, so if you take runner A, and you've got to remember which line is runner A. So here's runner A's line, and it asks after 2 hours. So we come out here to the 2 hour mark, and we go straight up, and runner A is 4 miles. And again, she said it right, 4 miles from the school, right? Because anything you reference, you need to reference by the wording that the graph gives you. And here we've got 4 miles from school. Good. Okay. Let's see. Let's look at Bonnie's scooter ride from home to the mall. Camden, what is happening in section AB? Right. She's traveling 20 miles per hour. And the way we got that is it's distance over time. And the distance from A to B is 40. And then the time from A to B is 2 hours. And when you reduce that, you get 20 miles per hour. And then that's the 20 miles per hour for how long? We didn't really talk about this much yesterday, but it's 20 miles an hour for how long? For 2 hours. Okay. Let's see. Dylan, what is happening in section BC? Stopped for what? Yep. Stopped for 2 hours. Okay. You need both. And that's why really, that's what I was saying here. You really need that it was for 2 hours, because you need the stopped, which is the speed, the distance traveled, and then the time is 2 hours. The reason the miles per hour kind of gets you out of really this being so necessary is because miles per hour does distance and time kind of in one. So I wouldn't count off on a quiz if you were missing the 2 hours there, but I would count off for number 9 if you were missing the 2 hours, because stopped just references distance. Okay. Okay. What is happening in section CD, Taylor? Say it louder. Okay. But when we describe it, we describe distance over time. So how much distance did she cover from C to D? Huh? 10 miles. Okay. And over time, how much time elapsed? 2 hours from C to D. And so what is her rate? Good. 5 miles per hour. Okay. Again, right, when it asks what is happening in a section where there's distance over time, you always write your answer as whatever miles per hour. Okay. All right. Where is Bonnie at point A, Mary? She's home. And we get that from the title of the graph. And then where is Bonnie at point B, Jacob? Good. 40 miles. And again, you got to reference the graph. So from home. And then Laura, how about where is she at point C? Yep, still 40 miles from home. So same answer. And then where is Bonnie at point D? Shayna? At the mall. Good. If you said 50 miles from home, you're only partially correct. So if it was a quiz, you'd get a half credit. But because the title of the graph tells us from home to the mall, we know that her ending point is actually the mall. Okay? If we weren't given the to the mall part, we could say 50 miles from home. All right. Which segment has the fastest rate, and explain without using their speeds? Alexis? Okay. Well, let's look at the graph and see. Let me make it bigger here. Which segment do you think is going fastest without looking at any of the speeds? A to what? A to B. So the answer for which segment would be this segment AB, and then why did you pick AB? Yeah. Because it's where it has the steepest slope. Okay? Good. Grace, how did Bonnie get from home to the mall? Her scooter, right. And again, that's just kind of one of those that helps you to gather information from the title. Very good. All right. That is all for 9.1. Any questions on 9.1? Okay. Make sure if it asks you what is happening in a segment, if you're given numbers for distance and time, you have to tally miles per hour. Okay. You can't just say increasing in speed or increasing in distance. You have to tell me the miles per hour. Okay. Go ahead and pass that over and up. You have 9.1 done. Will you pass the paper clip over? And whoever gets it, you can put it under the tray because these are already in the grade book. All right, now we're ready to go over 9.2. So 9.2. All right. Now, in the video for 9.2, we talked about a different way to reference a point. And if they're not labeled, like in this graph, we don't have an A, B, C, and D, we can use the bottom axis, which in this case is time, and we can reference different points by saying T equals, and that tells us where along that bottom line we're referencing, okay? So we've got Sarah left school and rode her bike home. The graph shows the relationship between her distance and her time, and we know if it's distance over time, our answers are always going to be in miles per hour. So where did we leave off? Are we with you, Gage? All right. So explain what happens between T30 and T40. So let's look real quick just for those at home. T30 is right here, and T40 is right here. So what is going on between T30 and T40? Perfect. Yep. Rested or stopped. Either one works for me. And, oh, my pin's jumping. For, I don't know what's going on with my pin. It keeps jumping on me. See if I can try it again. There we go. Rested for 10 minutes. Good. Okay. The rested references the distance. No distance was traveled. The 10 minutes references the time, so you're referencing both axes, so you're perfect. All right. Michaela, explain what happens between T equals 0 and T equals 30. So let's get rid of this line and put a line at T equals 0. All right. What happens in T equals 0 to T equals 30? Okay, good. So, and you're right. So let's talk about how you got that. So from 0 to 30 is this distance traveled, and that is 1 mile. And she did that in 30 minutes, right? She went 1 mile in 30 minutes. And since you want it in miles per hour, you have to make that 30 minutes a 60 minutes because that's 1 hour. And so to do that, you multiplied by 2. So that means we multiply the top by 2. So we get 2 miles in 60 minutes or 2 miles in 1 hour. So that lets us write it 2 miles per 1 hour. Okay, good. Bryn, where is Sarah at T equals 50? Yeah, and again, we get that from not even the title of the graph, because the title is just distance from home or distance from school, but in the directions it says that she left school and she rode home, so that means her ending point would be home. Good. Any questions on that graph? All right, so the next graph is our first look at speed along the y-axis. We talked about in the video how that changes how you answer things. Camden, what is happening between point A and point B? Right, so she maintains 8 miles or 50 miles per hour for, and then it looks like it's about 8 minutes, 8 minutes, 10 minutes, depending on how you looked at the graph. There's no lines on this one, so it kind of makes it difficult, but that works as long as you're close. All right. Dylan, what is happening between point C and D? That's all right. You're still going to look at it and tell me. What happened between point C and D? So here's point C and D. So if you follow it over, what's happening over here? Yeah. Staying at or maintaining. Okay. Maintaining 65 miles per hour for 5 minutes. And you might have said 64. So it's like I said, without lines, as long as you're in the right vicinity, we're good. And then from about 10 to 15, so that's about 5 minutes. Okay? Good. What is happening between point D and E? Taylor? Say it a little bit louder, hon. I'm sorry. Right. She slowed down, and you can put from 65 to 40, or you can put slowed down by 25 miles per hour. Either one works perfectly for me. And then how long did it take her to do that? Slowed down to 40 miles per hour in how long? About 1 minute. It's close. Yeah. Again, without lines to be exact. As long as you're close, we're good. Okay? How long does it take Natalie to get to work? Mary? Yep, 20 minutes. And it always cracks me up on these graphs. 20 minutes. It always cracks me up on these graphs. She gets to work and she's traveling 40 miles an hour. And apparently she's got some magical car that just stops on a dime. Because technically what should happen is we should have a gradual slowdown. But apparently her car can just go from 40 miles an hour to 0. Right? I said she Tokyo drifted into her parking spot and just stopped. Like she watched too many Fast and Furious movies.
You should see her pull out of the parking spot like 20 miles per hour.
Oh my. So you're why we have graphs like this. Is this what you're telling me?
She really, like, goes out so was in a hurry, so I watched her park.
Oh my.
And then there was another time my brother was parked and his dad was parked behind me in his truck. And I forgot he was back there, and I backed up, and I almost hit his truck.
Oh my.
To total it.
So you're the reason we have graphs that start and stop like that. Is that what you're telling me? All right. Okay, real quick, since we're recording, we need to keep going, guys. All right, so number 3, Maria rode her bike home from school. The graph shows Maria's distance from school over time. So again, right, we've got distance over time, so we know a lot of our answers here are going to include miles per hour. Describe Maria's bike ride with respect to time and distance. And that should tell you, when you see respect to time and distance, that should tell you miles per hour. Be sure to include each segment, what is happening, and changes in speed during the entire bike ride. So it says include each segment. So we're going to talk about segment A, B, C, right? Those are the segments that we're going to discuss. So in segment A, where did I leave off? Somebody help me remember. Where did I leave off? All right, Jake. Segment A. What is happening in segment A? Right, so we went 1 mile in 30 minutes. So can that be our answer? It always has to be in miles per hour, and that's a half hour. So, Gage, what would we do to the bottom here? Yeah, we want to make the bottom an hour, which is 60 minutes. So we're going to multiply by 2, which means we multiply by 2. So then our answer for segment A is that she was traveling 2 miles per hour. So Maria left home. No, she's traveling to home from school. So Maria left school, traveled 2 miles an hour for 30 minutes. Okay, that's the first thing we would describe. Then, Laura, what happens in segment B? Okay, she stops for 10 minutes. Good. And then, Shayna, what happens in section C? Here's section C right here. How far does she travel in section C? From 1 to 1.5. So how far is that? 0.5? You see what I'm, look up at the screen and see if you can see what I'm drawing the lines at. So we're just talking about section C, and it's from 1 to 1.5. So what's that little distance there between, and I'm kind of making it hard to see because I'm covering the numbers, but between 1 and 1.5 is how far? Half a mile? Okay. So she goes 0.5, and then how long does it take her to do that? Just segment C is 10 minutes. Okay, now can we leave it like that? Okay, Shayna, what do we need to do to the bottom to make it work for 1 hour? We want it to be 60, so what do we need to multiply it by? We multiply 10 by what? Somebody help her out. What will we multiply 10 by to get it to equal 60? 6. Okay, so if we do it to the bottom, we do it to the top. What's half of 6? 3. So 3 miles per hour for 10 minutes. Okay. So we reference the speeds, which is what it asked us to do there at the bottom, right? And the change in speed. And so you would write this out that Maria left school, traveled 2 miles an hour for 30 minutes. Then she stopped for 10 minutes. Then she traveled 3 miles an hour for 10 minutes and then arrived at home. Okay, so that's how you would write that out or type that out for the description part. Okay. All right. Next we have Lexus. We want to know what is Kate's rate. And so we have distance over time here. So what's our distance for Kate? Okay, so let's break it down into, we've got this 1 hour mark, right? So we want, which one's Kate? Kate's the, I'm going to do it and try to do it in a different color. All right, here's Kate, all right? So Kate goes from here to here in 1 hour. So how far does she travel in 1 hour? 1 mile in 1 hour. So we can just write that 1 mile per hour. Good. And then what is Susan's rate, Grace? Okay, so Susan in that 1 hour goes from here to here, which is what? 0.5 over 1, which is 0.5 miles per hour. And should that should flesh out. If you look at the steepness of Kate and Susan, which one is steeper? Anybody? Kate's is steeper, so if you get a steeper line, you should get a faster rate when you tally it. If you don't get a faster rate, or if you get identical rates, if you get identical rates for Kate and Susan, you should look up at the graph and their lines should be right on top of each other, right? Or they should at least have the exact same slope. If they don't have the same slope, they can't have the same speed. I'm starting to lose my voice. Okay. What is the ordered pair of where they meet? Gage?
4-3.
Good. 4-3 is the ordered pair, X first, then Y, and then use the soft brackets. What does the Y-intercept mean for Katie? Michaela, what's the Y-intercept mean for Katie?
She started a mile away.
Katie did?
No.
I think
Susan, but Katie.
the Y-intercept for Katie. Katie's the blue line up there. So where did Katie start? At the pool. She started at the pool because Katie's line is the one that they kind of crisscross. So if you have a highlighter or colored pencils or anything to help you kind of track which line is which, because when they cross like that, sometimes it's easy to flip-flop who is who. That's fine to do on your papers and quizzes and stuff. All right. Bryn, what does the x-intercept represent in this graph? Time. Good. Yep. Time in hours. Good. Perfect. All right. Any questions on this one? Okay. I'm going to pause this if I can. Yeah. Okay. So this is the new part that I was telling you about. This is the part that we haven't really seen one like this. I mean, we've talked about it, but we haven't seen one exactly like this. So I wanted to go over it. All right. I'm going to make this bigger, but the questions here are what segment would be walking, running, resting, and jogging. Okay. So that's what we're looking at here. I'm going to make this bigger though. So we want to know when they are, walking, run, jog, and rest, right? Those were the 4 things that asked below. So let's do the rest and the run first, because I think those will be the 2 easiest. So in this graph, which section is resting? Keeping in mind that it's a distance, not a speed. C. So let's do that one easy. That one's the first easy one. So C is definitely resting because it's flat. Where would you say would be the run? Because of those, that's the fastest. B. All right. So that leaves us A and D. You've got a walk and a jog. Obviously, a walk's a little bit slower than a jog, not as fast as a run. So between A and D, which would you say is the walk and jog? A is the what? A is the jog. And D is the walk. Good. So see what I mean by, we've done it before. We've talked about how the slope changing is referencing a change in speed, but we hadn't done one exactly like this where we had kind of talked about the difference between walk, jog, and run. So I wanted to make sure we covered it. Any questions on that? Steepest is always going to be your fastest. Completely flat is going to be a rest. And then the different variations in steepness are variations in speed. Any question there? All right. We're going to practice on a speed one here. So what is happening we're going to look at B, F, D, E, and C. So I'm just going to go ahead and blow this up so we can see it. And we'll just actually go through the whole graph. All right. What's happening in A? Started and then what? No, they don't stop. Right. No, just in A, they don't stay the same speed. In A, what do? They increase, right, over a period of what? And this is where you got to know how to pull apart a graph. Yeah, this is a 15. Oh, man, I don't like that fat one. I'm fat shaming my pen. All right, so this is 15. This is 45. This would be 75. What? 105? 135. 165, right? Because each one of the ticks equals 15. So from A to B, they increase from a stop up to 40 miles per hour over 15 minutes. Okay? So this is not Laura driving. All right. What happens in section B? Right. They maintain what? For how long? Yep, from 15 to 60, right? So just for that segment of B, so for 45 minutes. Because remember, when you're explaining a segment, you want to explain both axes. So we talked about the speed and we talked about the minutes. All right, very good. How about in C? What's happening there? To a what? Yeah, they decrease speed to a stop for over how long? 15 minutes. And then how about D? Yep, they stop for 15 minutes because when it's a speed on the x-axis, stop means they're here at the very bottom or at 0 miles per hour. So definitely a difference in what makes a stop when it's a speed graph over what makes a stop when it's a distance graph. All right, what happens in segment E? Good. They increase their speed to 60 miles an hour, and it took 30 minutes for that to happen. Good. And then what happens in F? Good. Maintain 60 miles per hour for, what did we say, 30? Yep, because it's from 120 to 150, so that's 30 minutes. And then how about section G? Good. Slow to a stop or decrease their speed to a stop over, how long did it take them to do that? From 150 to 180, so for 30 minutes. That's a slow down. All right, are we good on how to pick apart a speed graph? You guys seem to do pretty well with that. All right, let's see. This one cracks me up. See if you guys can figure out the weirdness of this. All right, so it says, write a scenario for the graph describing each segment along Eric's walk to a friend's house. And this says distance from home. So what do we know this spot right here is? Whoops. What is this spot right here? That's home, right. That's 0. It is 0. No, you were right. It is 0. And we know that 0, because it's distance from home, we know that 0 is home. So we're going to write a scenario, and I'm going to use a text box because I'm not even about going to try to write this all handwritten. All right. So tell me what you guys think. We're going to write a scenario. What happens here? Eric does what? Where does he leave? Okay. He leaves his home. Goes what? What's he do in segment A? He goes 30 miles per hour for how long? 2 hours. Okay, now what? Okay, but we're writing a scenario here. Where's he at section B? Yeah, but where was he going? Yeah, stops at his friend's house for how long? For 4 hours. And then what? He goes back home at what? 30 miles per hour for how long? For 2 hours. Right? And he arrives home how many hours after he started? 8 hours after beginning. All right. So that's what it's asking you to do, is to write a scenario. You got to know where he's at B, that flat spot. You can't, hey guys, it's not enough just to say he stops. Because they say he's going to his friend's house, you need to realize that B is his friend's house. And then he travels back home. And we know he goes back home because he goes back to ground 0 right here, which we've already established is home. What's weird about this? Anything that you could possibly imagine? Right? He's walking faster than I can ride a bike. So Eric is quite the speed walker. I think we should probably change this to he drives, but hey, it's fine. And then I don't think we need to go over this. I think you guys are pretty good with this. The main thing here is just realizing they don't both start at 0. And if they crisscross, keep track of A and B, where they start and where they stop. Any questions? Are we good? All right, quiz is tomorrow in class. Virtual students, quiz tomorrow. You need to be on a video call with the camera running in order for me to unlock your quiz. I will see y'all tomorrow.